Hello, beautiful people, and welcome. In today's video, we are continuing part 1 of the sequences and series for your unit test. Now, this will cover questions 5 through questions number 10 on your pretest or your practice test. As always, I am human. If I make a mistake, that's okay. Let me know where this mistake occurs so that way I may learn from it. And I already, you guys, put in a geometric series formula here in this thinking bubble and a geometric infinite series formula in this bubble. Now remember, for the infinite formula, you have to check if this converges or diverges. And if it converges, then we can use the formula. If it diverges, we cannot. All right, let's go ahead and jump in. So evaluate each geometric series described. So in this one, they give us a series, but a list of numbers as well. So let's go ahead and write out our formula. So we have S sub n is equal to a sub 1 times 1 minus r to the nth power divided by 1 minus r. So in this formula, we need some kind of information. We need our n value, or the total number of terms. This is what they give us. We also need the common ratio, which we need to find out. And then we also need to know what the a sub 1 is, or the first term in the sequence is, or in this series. So the first term in the series is a -4, so that's going to be our a sub 1. Common ratio is going to be, we're going to do 12 divided by -4, we're going to do -36 divided by 12, and we're going to do 108 divided by -36. Now this should give us all of the same numbers, and that means we do have a common ratio. If by any chance this when you check, it doesn't give you the same number or the same ratio, then you do not have a common ratio, and then you don't have to do anything. In this case, all of this is equal to -3, so therefore r is equal to -3. Let's go ahead and jump in, plug some numbers in, and solve for S sub n. So S sub n is equal to a sub 1. A sub 1 is -4. 1 minus r. Always put r in parentheses or else the negatives get confusing. So -3 to the nth power, n is 9, divided by 1 minus r, or 1 minus a -3. Do not, for whatever reason, I know you're going to want to, but don't put these two negatives together here. PEMDAS means parentheses exponents. You have an exponent inside of a parenthesis bubble. You have to evaluate that parenthesis first. That exponent first. So on my calculator, I'm going to do parenthesis, always do parentheses, -3 to the 9th power. And that gives me a -19,683. I'm going to write that here on this side. So I'm going to say we're going to continue off here. So that means I have -4 times 1 minus, again, parentheses, -19,683. And underneath, because I do only have subtraction with a negative, I'm going to go ahead and say evaluate this as 4. Continuing on, I'm going to say 1 minus this number, so 1 minus -19,683. I am doing that on my calculator because sometimes I just don't trust myself. So I have -4 times 1,000. Again, I keep saying 1,000. It's not. It's 19,684. And again, after we have evaluated with the exponent, these two negatives make a positive. Therefore, we have a positive value. That's still in parentheses, and we still have a 4 in the bottom. So what that means is we actually can do this both ways. If you wish to multiply by -4, then divide by 4, you may choose to do so. However, I am noticing that I have multiplication between -4 and this parentheses or the bubble. So I'm going to say I can cross out these 4s because I have multiplication. You can only do this with multiplication. Therefore, my answer is a -19,684. And you can write that as equal to S sub n, but we do know what that n is equal to 9. So the summation of 9 terms is equal to -19,684. Let's move on. This example gives us this same thing. We are evaluating the geometric series. In this case, they do give us the format in a summative format with sigma. Same thing, we're going to write the formula. S sub n is equal to a sub 1 times 1 minus r to the nth power. Now, why do I know to use this formula instead of the infinite formula? It's because of this upper limit. Because the upper limit gives us the position, or let me back up. The upper limit gives you the last position number. In this case, the last position, or the number in the 8th position is the last number that we're going to be adding in our series. This bottom number, m equals 1, this gives us our lower limit, or in this case, we start with the first number, we end with the 8th number, and we add everything else in between. This is our explicit rule. Notice that the explicit rule follows a formula, a sub 1 times r to the, in this case, m minus 1. You can say n minus 1. It doesn't matter what variable you use for m, n, or n. Okay, so because this is an explicit rule for when we have a lower limit of 1, we know that a sub 1 is 2, we know that r is 3. Now, this does change if your lower limit is not 1 or if your formula is given in a different format. The easiest way for you not to make a mistake is take your formula, plug in for your m or I or n, whatever the variable is, plug in your lower limit and solve for your a sub 1. That is the easiest way. You won't make a mistake that way. So I have 2 as my a sub 1. R, you have to get this from the formula. So R is 3. And the number of terms. So how do we find out the number of terms? Well, you're going to take your upper limit, which is 8. You're going to subtract your lower limit, which is 1. And you're going to add 1 for good measure. So you're going to end up with 8. So n is 8. So let's plug in. I'm going to switch markers so that way you can see it in a different color. I'm going to kind of box this area out. So I have s sub 8. We're going to calculate the sum of 8 terms. A sub 1 is 2. So we start at 2. Our common ratio is positive 3. And again, we're calculating 8 terms. And 1 minus 3. 3 to the 8th power. I'm actually going to do this all on my calculator. I'm going to evaluate the numerator. I almost forgot what that's called. Numerator all in my calculator. So I'm going to say 2 parenthesis 1 minus parenthesis 3 to the 8th power parenthesis. So I'm kind of grouping 3 to the 8th power inside of parentheses, inside of parentheses. And that's all in my numerator. I'm going to press enter, which gives me, let's see if I can say this. Oh, that looks weird. So that gives me negative 13,120, and I still have divided by 1 minus 3, which is a negative 2. So negative 13,120 divided by negative 2, and that gives me 6,560 as my sum of 8 terms. I'm going to move my calculator so it doesn't clash with the camera, and you can see this a little bit better. Again, don't worry about this hiccup. Even though it doesn't look pretty, your work is here. Let's move on to question number 7. Question number 7 says, determine the number of terms. So this is one of the longer ones that we had in the first part. I think it's either question number 3 or 4 for the arithmetic. This is now for the geometric. They give you your S sub n. They do not give you your upper limit. That is what we're trying to solve for. They do give you your lower limit of 1, and they do give you your explicit rule. Again, explicit rule, make sure you have your formula sheet. That means this is a sub 1, and that means this is r. Starting out with your formula, S sub n is equal to a sub 1 times 1 minus r to the nth power divided by 1 minus r. Why did I put that in parentheses? I don't know, just have it. Let's start plugging stuff in. So S sub n, we already know what S sub n is. 37,324. That's equal to a sub 1. We got that here. And again, if you're not sure what a sub 1 is, take your lower limit, plug it in, and you're good to go. So a sub 1 is 4 times 1 minus r is 6. To the nth power, we don't know what n is, so we leave it. And then 1 minus what is our value. Again, I always feel like a pirate when I say that. Our R value is 6. Starting to simplify this, so I have 37,324 is equal to 4 times 1 minus 6 to the nth power. Keep your r in parentheses. It will save you a headache. 1 minus 6 is negative 5. At this point, multiply. Our task is to get 6 to the nth power by itself. We can't do that unless we get rid of everything else. So the first thing you need to get rid of is you need to get rid of this divided by negative 5. So how do we get rid of that? We're going to multiply both sides by negative 5. So what do we have? Calculator time. I have 37,324 times -5, and that gives me negative 18. Oh, it's not even 18,000. It's 186,620 is equal to 4. I'm going to put a little arrow there so we know that it's just moving on. 4 times 1 minus, again, parentheses for your R value, 6 to the nth power. Again, bubbles. So you have 4 times this bubble. So we're going to undo that by dividing both sides by 4. Now I do still have my value in my calculator, so I'm just going to simply divide that by 4 without having to type anything in. Again, I'm going to do my arrow. Typically, you don't do arrows in math. I'm doing it just so you guys can see kind of where I'm going. So I have negative 46,655. That's equal to 1 minus 6 to the nth power. Now, if you're in my class, you saw that this technically is 3 different parts. It's 1, it's minus, and it's a negative 6 to the nth power. 3 different things. So the first thing you need to do is get rid of that 1. So I'm going to subtract 1 from both sides. So you have negative 46,656 is equal to negative 6 to the nth power. Again, that negative is outside of the R value. It's outside of that 6, so we need to get rid of it. We need 6 to the nth power. So I'm going to go ahead and in my head multiply by -1 on both sides. You can also choose to divide by -1 both sides. Ultimately, all you're doing is flipping the signs of both. -6, that becomes a positive 6 to the nth power, and then this very large number becomes positive as well. At this point, you are trying to do the one-to-one property or the same base property where you're going to be rewriting this large number with a base of 6. Once you have the bases equal, you can then set the exponents equal to each other, and you're going to have your answer for your n value. So how do you find out what this exponent is? It's a marvelous game of guess and check. So I'm going to say 6 to some power. What that power is, I don't know. Let's try 6. And you guys, I promise I did not plan this, but apparently the answer is 6. So I need 46,656, and I have 46,656. Totally didn't plan this. So let's see. That means I have an exponent of 6. That means n is 6. So to determine the quantity of terms, our final answer is 6 terms. Moving on to number 8, it says determine if each geometric series converges or diverges. This was part of your quiz if you are in my class. So if it converges, you're looking at the absolute value of R. A lot of the hiccups that happened on the quiz were you were not looking at the absolute value. You were just taking the value, whatever you get for R, and then making that determination if it converges or diverges. Don't do that. You have to take the absolute value. Even if it's in your head, you have to do it. If it's in the quiz, that's the information I need. I can't really tell what's going on in your head unless you tell me. So you're looking for the absolute value of both R. So if it is greater than 1, if the absolute value is greater than 1, you are looking for something that diverges. If the absolute value is less than 1, then you are having something that converges. If it converges, you then do have a sum. If it diverges, it has no sum, or the sum does not exist. So let's see what this is. We're going to take -4/3, divide that by 2. We're taking -8/9, divide that by -4/3. And we're going to take -16/27 and divide that by -8/9. Now, if you don't have a calculator that does fractions for you, what you can do is you can do this by hand. I think it might be quicker for us to do it by hand than me typing all of that in. So divided by means we're dividing by fractions, so we're going to multiply by the reciprocal. So I have -4/3 times reciprocal of 2 is 1/2. I have -8/9 times -3/4, and I have -16/27 times -9/8. And then if you notice that a lot of things kind of just cancel out. So I have 2 goes away. Maybe I shouldn't do purple on purple, but 2 goes away. This is 2. So we have -2/3. 4 goes away. 4 goes into 8 twice. And this goes away. This is 1, 3. So I have 2/3 as well. And I'm looking, oh, you guys, I'm like, why is one positive, one negative, right? So I forgot the 2 on the negative on the 2, so this should be a positive as well. So I'm guessing my R value is 2/3. So then I have 2, thirds, negative, negative. Yep, my R value, 2/3. Now this is where a lot of you made that hiccup. You went from here to already saying, is this converging or diverging? Make sure that you say that the absolute value of 2/3 is 2/3, which means it is smaller than 1, so it converges. Again, I am okay if you do this step in your head. However, on an assessment, I can't know that that's what you're doing unless you tell me or show me that that's what you're doing, so be careful. Moving on, almost done. We have 2 more after this. So question number 9 is asking you to evaluate each infinite geometric series. Now be careful. Anytime you see infinity or a ... in a series, that means you have to determine if this converges or diverges first. Because if it diverges, you're doing a happy dance. You don't actually have to do the problem because a sum does not exist. So let's determine if it converges or diverges. Look at your formula. This is an explicit rule for something starting at 1. That means this is your a sub 1 value. This is your upper limit. Again, it's infinity, so an upper limit, there is no upper limit. It's infinity. That means this is your R value. That means the absolute value of 0.8 is 0.8, which is smaller than 1, which means it converges, so we move on with our formula. Now, looking back at the beginning, I did provide the formula, which is here. That's what I'm looking at. I have S is equal to a sub 1 over 1 minus R. Now, something I want to point out with the formula, I do have an infinity here. A lot of times for your notes, a lot of times you don't see an infinity there because you're not taking the sum of infinity. I sometimes like to put it there just to remind myself that that's the infinite formula. However, a lot of times you won't actually see the infinity next to S. Pretty simple after that. S is equal to a sub 1, in this case is 5, and 1 minus our R value, which is 0.8. Typing that into the calculator, you can do this all in one step. Let's clear this out first. So I have, again, you can't see this, but I do have it here. I have 5 divided by everything in parentheses, 1 minus 0.8. If you wanted to put 0.8 in parentheses, like a secondary parentheses, you can. Sometimes that does help if you have a negative R value. Press enter, so it converges to 25. Last problem, we have question number 10. A sub 1 is 24, S is 16. Determine the common ratio. Again, common ratio is R of the infinite geometric series. So if they're asking you to solve for a common ratio, the number of terms, they have to tell you what type of series it is. Is it geometric? Is it arithmetic? Is it infinite? Is it finite? So in this case, they told us it's infinite geometric series, so we know what formula to use. And because a sum exists, that means there is a common ratio that is smaller than 1 when we take the absolute value. Now, R can technically be negative. R can be negative, but the actual absolute value needs to be smaller than 1. So the first value that they give us is they give us an a sub 1, which is 24. We don't know what R is. That's what we're solving for. However, they did tell us that it converges to 16. So what do we do? In this case, you have 2 options. Option number 1 is take the entire denominator and multiply by the entire denominator, both sides. So you're left with 1 minus R in parentheses times 16 is equal to 24. That is option number 1. After that, you get to divide by 16. Don't distribute. Your objective is to get R by itself. R right now is in a bubble, and that bubble is attached to 16. So get rid of anything outside the bubble first before you do anything inside the bubble. So you have 1 minus R is equal to 24 divided by 16. So I'm thinking 16, 4 times 4 is 16. I don't know why I'm having difficulty with this right now, but that's okay. Let's do this the long way. I'm going to divide top and bottom by 4. So that means I have 4 over 6. I still can divide by 2. I should have divided by 8. Okay, so I have 2, what is this, thirds? So I have 2 thirds. And then I'm going to add 1 to both sides. So I have negative R is equal to 2 thirds plus 3 thirds. Again, I'm converting that 1 to 3 thirds. And again, I'm trying to squeeze everything in here because I want to leave some space for me to show you the other way, which is negative r is equal to 3, 4, 5/3. And so r is equal to negative 5/3. And you guys, I was able to find out what the issue was. So if you look here, right here, that should be a -1. So remember how I originally said that because we know a sum exists, that our absolute value of r needs to be smaller than 1. 5/3 is not smaller than 1. So I know that I made a mistake somewhere, and I was able to find the mistake. Do you see how I have a 1 and I added 1? That should be a minus. So that means minus, minus. So 2 minus 3, this should be a negative 1/2. A negative 1/2. So my answer, let me cross this out so you guys not too confused. So it should be negative 1/2 as my answer because this should have been a -1. I'm going to show you a different way to solve this. It's just the first couple steps. So once we plug everything in, we had 16 is equal to 24 over 1 over r. Over 1 minus r. What you can do is you can create two fractions. So here's a fraction, here's a fraction. I made 16 a fraction by putting a 1 underneath it. Take both fractions and flip them. So I have 1 over 16 is equal to 1 minus r over 24. Then continue solving. I will go ahead and really quickly redo it because I feel like this is messy at the end. But now you are left with multiplying 24 both sides. So you have, after that, you have 24 over 16 is equal to 1 minus r. And if you look here, you're already at 24 over 16 here. So then I'm going to subtract 1, which is the hiccup that I had last time. I'm going to subtract 1 both sides. So I have minus r is equal to, and I did simplify here. I'm not going to simplify here. I'm going to see what happens. I have 24 over 16 minus 16 over 16. And see if we can wait to simplify. 24 minus 16, that is 8. So I have 8 over 16 is equal to negative r. And again, it should give us the same answer. So that means I have 1/2 is equal to negative r, which again, we're flipping the signs. So I have a negative 1/2. Hopefully this is a little bit easier to read without the mistake that I made on the other side. So the only difference here is taking all of the denominator, multiplying both sides by it, not distributing, dividing by 16. This way you create a fraction with 16. So 16 over 1. Take both fractions, flip both fractions, and then continue solving by multiplying by the denominator here. All right, beautiful people, go ahead and continue watching part 2. Thank you for watching this video, and I will see you in the next one. Bye.